In this lesson, we're going to talk about race conditions and the vulnerabilities associated with them. Now, what exactly is a race condition? Well, a race condition is a software vulnerability that occurs when the resulting outcome from the execution processes is directly dependent on the order and timing of certain events, and those events fail to execute in the order and timing intended by the developer. Now, essentially, this is a complicated way of saying that the computer is unexpectedly trying to race itself in the processing of certain types of data. For example, if you're trying to do something legitimately and the attacker is trying to do something malicious at the same time, they might be able to get their request in right before yours so they could take advantage of a race condition vulnerability in the program's code to run their processes before you can run yours. Race condition vulnerabilities are found when there are multiple threads attempting to write to a particular variable or object at the same memory location at the same time. Now, one of the ways this can happen is by a dereference or no pointer dereference exploit being exploited to trigger that race condition. Dereferencing is a software vulnerability that occurs when the code attempts to remove the relationship between a pointer and the thing that that pointer was pointing to inside of your memory. Dereferencing will break the reference pairing between the pointer and the thing it was pointing to in memory, and this allows changes to the location of memory or the variable that contains that memory location. Now, race conditions are difficult to detect and mitigate in our modern networks. The dirty cow exploit was extremely popular back in 2016. It's an excellent example of a race condition that was being exploited. COW is actually an acronym, and it stands for copy on write. In the dirty cow exploit, the Linux operating systems and some Android devices were being exploited to allow a local privilege escalation to occur by exploiting a race condition vulnerability based on the implementation of the programming for the copy on write function that was used inside of the kernel's memory management system. Now, because a race condition existed in this code, if the attacker used the right timing, they could exploit the copy on write mechanism to turn the read-only mapping of a file into a write mapping. This would allow the attacker to have escalated privileges because they can now write to a file even though they're only supposed to have read access to that file. Now, what made this exploit even more dangerous is that it was difficult to detect because it didn't even leave anything inside of the system logs to let you know that it was happening. And this is why race conditions are so dangerous, because they often happen outside of the normally logged processes on a given system. While the dirty cow vulnerability allows a race condition against the memory management system, race conditions can also be used against databases and file systems too. When race conditions are used to exploit a database or file system, they're generally going to take the form of either a time of check, time of use, or time of evaluation vulnerability. Now, first, we have a time of check vulnerability. A time of check vulnerability, also known as a TOC vulnerability, is a type of race condition that occurs when an application checks the state of a system resource, such as a file or database record, and then makes a decision based on that check. But then, an attacker is able to manipulate the state of the resource before the application's operation actually occurs. For example, an application might check if a user has sufficient funds before initiating a bank transfer. However, if there's a significant time gap between the time that the check occurs and the actual money transfer happens, the attacker could potentially initiate multiple transfers in that time window, which could end up overdrawing your bank account. Second, we have a time of use vulnerability. Now, a time of use vulnerability, known as a TOU vulnerability, is a type of race condition that occurs when an attacker can change the state of a system resource between the time it is checked and the time it is used. This is similar to the time of check vulnerability, but it focuses more on the time that the resource is used instead of focusing on the time that the check was conducted. Third, we have a time of evaluation vulnerability. Now, a time of evaluation vulnerability, also known as a TOE vulnerability, is a type of race condition that involves the manipulation of data or resources during a time window when a system is making a decision or evaluation. For example, the attacker might manipulate inputs being used inside of a calculation to cause incorrect results to be used instead. To protect against a race condition, you can use locks and mutexes to lock resources while a process is being run. Now, a mutex is simply a mutually exclusive flag that acts as a gatekeeper to a section of code so that only one thread can be processed at a time, and this helps prevent race conditions from occurring because we're not going to have that concurrent execution of the code or function because of that mutex being there. Now, most databases have a method that can be used to lock a resource while it's being processed. For example, if you've ever used SharePoint at work to access a particular file for editing, it actually puts a lock on that file so that other people can read the file while you're editing it, but nobody else can check the file out for editing while you have it in use. This prevents two users from changing the file at the same time and helps us to maintain version control over our files. This same concept is used when locking a record in a database or using a mutex to lock out the execution or function of a particular part of the code until the other thread is completed. Overall, the use of locks and mutexes works pretty well to prevent race conditions, but sometimes they can cause a deadlock to occur. Now, a deadlock occurs when a lock takes effect, but the process that the lock is waiting for is terminated, crashes, or simply doesn't finish properly, which causes the lock to never be removed from the resource, even though the processing was completed. When this occurs, the system or code can lose access to the resource until the lock is overridden or manually removed. To prevent deadlocking, it's important that you properly design and test any locks or mutexes that you're using inside of your code to prevent a race condition. So remember, a race condition is a software vulnerability that occurs when the resulting outcome from the execution processes is directly dependent on the order and timing of certain events, and those events fail to execute in the order and timing intended by the developer. There are three main types of race conditions that you might come across in the real world, including a time of check vulnerability, a time of use vulnerability, and a time of evaluation vulnerability. All of these race conditions can have serious implications on the security and reliability of your software applications. Finally, it's important to remember that to prevent a race condition from being successfully used, you need to mitigate these vulnerabilities by using mutexes or resource locks.